Hello, and welcome to the penultimate talk of the day. Everyone still awake? Yeah. Well, I heard some noises, so that's a good sign. You're all waiting for the raffle, aren't you? Okay, that was a good trick, that one. I can't believe that this is the first ever instance of Full Stack Europe. This has been an awesome conference. I've already committed to a conference sticker here as well, so you better do another one, because otherwise I have to take it off, and stickers don't come off. So yeah, let's talk about some types. So as Freak said, my name is Kadi. I work at Formidable, which is a JavaScript consultancy. We're based mainly in the US and in London. And as a JavaScript consultancy, we mostly specialize in React, React Native, GraphQL, Node.js, that kind of stuff. So as a JavaScript consultant, I write a lot of JavaScript. But to be more specific, I think I should say I write a lot of TypeScript. And lately, this is how I've been feeling about the TypeScript. It's an amazing tool for the problem that we're having, but a lot of the time, I'm like, why am I even doing this? Why am I using TypeScript? Is there another tool? What else is out there? So JavaScript is pretty obviously on the type train. This is the type train. We've got TypeFlow, we've got TypeScript, but you might notice that there's quite a lot of space on this type train. So if you're a Python developer, as of PEP 484, you can have static typing in Python. And also, as I found out, there's quite a lot of PHP developers around. And I've Googled this, I'll be honest, I didn't know this before, but there's also static typing in PHP. So it's not just a JavaScript thing. I know JavaScript is a language that's pretty famous for going to other languages and nicking good concepts because we don't have anything ourselves. But the whole static typing thing, other languages are doing this as well. But why? This is what I am hoping to explore in this talk. I'm going to talk about why we are adding typing to our untyped languages, what are the benefits, what are the trade-offs, and what else could you do? Right, first, let's talk about the stack. This being Full Stack Europe, the stack can be interpreted to be various things, but my interpretation of the stack is the web developer stack. So we've got the front end, which is your browser, and then the back end, which is anything on a server side. Now, if we look at languages in these two areas, on the front end, on the back end, we are spoiled for choice. Python, Ruby, PHP, Java, go crazy, do whatever. On the front end, we are kind of stuck with JavaScript. JavaScript is king, hence the crown. And when JavaScript originally was created was the Netscape browser, no one really expected it to really take off. It was like, just a little hack, just make some things whiz around on the browser. And it was really cool, it was really successful. And then all the other browsers that came after were like, yeah, this JavaScript thing is awesome, let's also support that. And now we're stuck with JavaScript. So for this talk, I am primarily going to be referring to JavaScript, even though the static typing stuff applies to other languages. This is because this is a full stack conference, so all of you have, well, at least most of you, have written some JavaScript, whether you enjoyed it or not. And as a JavaScript consultant, it's all I know. So let's talk about JavaScript. Props to you if you recognize this image. My examples won't be anywhere near as entertaining, but I just wanted to have a duck in my slides. So I've written a function. It's a very exciting function. It's called add-on. It takes an array as an argument, so I named it an array, and it maps the array, and it returns the same array, but with each item in the array incremented by 1. So I'm expecting a number array, and I'm returning a number array. Now, if I pass in an array with 1, 2, 3, it returns 2, 3, 4, which is what I would expect. Now, what would happen if I called this with an object? I get a type error. And that's pretty annoying, because that's an error that the user will get. So what I would like to do, so I've written this function. I know that it's meant to be adding 1 to every value of the array. And other developers might not know. They might not speak English or understand my intent. Or this might be a much more complicated function. And I've got a couple of options here. So I could always add comments. I'm only joking, no one reads comments. I don't read comments. I sometimes write comments. But yeah, so that's an option, but not really a real option. Well, I could always add a fallback. I could program defensively. I could check that the array is an array and that it consists of numbers. And then if it doesn't, I could just return some kind of default, like an empty array, which is technically still a number array, just an empty one. Otherwise, I can do my map. So this kind of solves the problem, but not really, because it doesn't help me if someone is misusing my function. So what could I do instead? Well, I could add explicit type information. That's what I want, really. I want to communicate as succinctly as possible that I'm expecting the array to be a number and for it to return a number array. So this is not valid plain JavaScript, but you might know where this is going. Newsflash. Typed languages are not new. Well, this is the opposite of a newsflash. It's not news, it's old. All programming languages have a type system. So even though you might not explicitly be typing your types, they are there. Under the covers, they are there. Because at the end of the day, eventually, your code, whatever kind of high-level programming language you write it in, will eventually be interpreted by a computer that will need a type for all of your variables. So all your variables will eventually be cast to something. So the difference between typed and untyped languages is really when the type checking is done. So if you think about an execution of a program, there's two steps. There's the compile time, and then there's the runtime. You might have heard words like strongly typed and weakly typed. In fact, I'll probably use them. Typed and untyped. And these are both colloquialisms, but what they really stand for are static and dynamic typing. So a strongly typed or a typed or a statically typed language is a language where the types are being checked in the compile time. So there is an explicit step before your program is actually run in which the compiler goes through all your code and checks for types. And then a weak or untyped or a dynamically typed language is a language in which the types are being checked at runtime. So JavaScript, our friend, it skips right through compile time, does not care, and goes straight to runtime. And if there are any exceptions, you will see them in your browser. Now, there are loads and loads of strongly typed languages. Here's just a few, for example, and they have a compiler. Here we have Gandalf, the compiler, looks at your code. If there's any type errors there, it goes, no, back to the drawing board, fix these, and then we'll talk about runtime. As a result, at runtime, you can still have errors, but you can't have type errors, or at least it's very, very rare to have type errors. Obviously, there have to be some downsides, because otherwise, why wouldn't everyone use static typing? Why is dynamic typing even a thing? Well, the number one downside is that it takes time. Compiling takes time. There's always a relevant XKCD, and this is my favorite, so you might be seeing this once more later. And time as a programmer and as a human, because it's limited, is our most valuable commodity. So we don't want things to take time. So that is actually a huge downside. And the other downside is verbosity. Adding type information is by definition, it's adding information. So even though in this example, the amount of actual code or text that I'm adding isn't that much, it will add up, especially if you do functional programming. What about the upsides? Well, there's fewer runtime exceptions. That's the main benefit, really. We want to find our errors before our users do. And fewer tests. I think every single developer in this room would agree that unit tests and end-to-end tests and all that kind of tests are useful, but I think most of us would also agree that we don't write quite enough of them. And this lets you write fewer unit tests because you don't have to write any tests for type correctness. All right, let's talk about dynamic typing. And this is the weakly typed side. Let's talk about the upsides. Well, conversely, it's faster. There's no compile step. And it's more flexible. This might sound like a downside, but it's actually really powerful. I can declare a variable, I can say that it's a number, and then I can redeclare it to be a string. And this is really, really powerful because you can build self-referencing functions that can be like very awesome to code, but on the whole prone to errors and runtime exceptions. So on to downsides, which are obviously the type errors, and it's harder to refactor with confidence. If you ever refactored anything in a large JavaScript code base, you've probably done that, kind of looked at the entire code base, thought you've fixed all the references, you cross your fingers, and you run it, and then something still blows up. So in summary, both sides have pros and cons. There's no silver bullet, nothing's amazing. But the difference between statically and dynamically typed languages is you can't make statically or strongly typed languages more dynamic, but you could go the other way. And that's why all the dynamically typed languages have been kind of glancing over to the statically typed languages and thinking, oh, what could we borrow that could make our type checking a little bit more efficient and kind of retain all the benefits we have from being dynamic. So how can I reduce type errors in a dynamically typed language? Welcome Flow. If you've not heard of Flow, Flow is basically ESLint for type checking in JavaScript. It works exactly the same as ESLint. It's not a language. It's a plugin that we use in your Atom or VS Code or Vim or whatever you use. And you will look at your code and then tell you if your types are correct or not. And if you're in the React community, as I am, about 2 or 3 years ago, this happened. Everyone was rewriting everything in Flow. I think it was React community in particular, because Flow itself came from Facebook, which is the same as React. So it was introduced at a React conference. All the React developers were like, yeah, Flow is amazing. Let's do all the Flow. Create a React app had Flow config by default. Create a React Native app had Flow config by default. All the Node modules started to be written in Flow. Yeah, everyone went Flow crazy. So what does Flow do? Well, so this is Atom with just a Flow plugin. And then basically it does what is called a static flow analysis, hence the name. And it looks at your JavaScript code and it infers types. So in this case, you can see I've got a constant that I'm assigning to 4, and then I'm trying to call split on it. But split is an operation you can only use on an array. And then Flow quite correctly tells me, I'm an idiot, I can't do that, please fix your code. But sometimes static code analysis is not enough. Thankfully, you can also enforce types. So this is a function where it's called random string, and I'm explicitly saying that I want the return type to be a string. Now you might see that there's 2 problems, because the thing that I'm returning is not a string or random. Flow can't do anything about the randomness, but it can tell me that I was expecting a string, but it's not a string. There's also a community for typing Node modules. There's a Flow typed community, so if you use third-party libraries, which you will, because our goal as JavaScript programmers is to write as little JavaScript as possible, you will use Flow types. So if the libraries you're using don't have Flow bindings, you can use Flow typed, so other community people would have written the bindings for you, and if they don't exist, you can add them. Awesome. Right, what are the downsides? Why aren't we all using Flow all the time? Well, I used Flow for about a year and a half, and I did enjoy it in the beginning. The configuration was hell. That is a genuine configuration file that I used in a React Native project for about a year and a half, and it's huge. The regex is mental. It's got like weird escape characters. I wouldn't recommend it. The other thing, if you were in the Flow community at the very beginning, especially, it tended to have memory leaks, and they would manifest as these giant Flow processes. I'm not sure if you can actually see how big it is, but this is an actual screenshot from when I was using Flow, and this is a single Pro process that takes 14.18 gigabytes of memory, which is quite impressive. And lastly, it's easy to ignore it, because Flow is just kind of syntax sugar typing, and your browser wouldn't be able to interpret any of these types anyway. You have to strip them all out before you ship to the browser, which means that you can completely ignore it. You have to rely on developer diligence in order to add it to your CI/CD process and actually get any benefits from it. All right, so this happened. I put this as now, but really I think it happened about a year ago, where suddenly you kind of hear everyone in the React community and like, oh yeah, we're not using Flow anymore, we'll kind of go to TypeScript. And all these like React packages are being rewritten in TypeScript. Create React app, I think it comes with TypeScript by default. Like everything has TypeScript. So why? Well, they are similar, but conceptually different. So whereas Flow is a static type checker, it checks your existing code without adding it, TypeScript is technically a language. So if you like sets, here is a set. So JavaScript is in the middle in its own little set, and then TypeScript is actually a superset of JavaScript. This means that every valid JavaScript program is also a valid TypeScript program, but not vice versa. So TypeScript is like JavaScript++. But in order to run this code in your browser, you still need to strip out the TypeScript types and go back to JavaScript. So this is using VS Code with a TypeScript plugin, and it does a similar thing. So this is the same example. It tells me that split doesn't exist in for, which is correct, it doesn't. And even though you can't see the function, it's the same function. So I get the same error with slightly different wording. And there's a Node modules community, but it's significantly bigger. This screenshot is actually from a couple months ago, so I'm sure it's more than 21,000 stars on GitHub. And configuration, it's significantly nicer because it's JSON. We love JSON. So easy to read. And finally, in terms of memory, whereas Flow was terrifying, TypeScript is not bad. It's not ideal, but if you've got a 2,000-pound MacBook Pro, you can definitely do it. So in summary, the React community in particular moved from Flow to TypeScript because of the community, the release cycle, the reliability. It was easy to set up, and it has an ability to actually enforce type checking, although you can ignore it. Now, just a side note about the size of the community, if you're not in the React community, you might be going like, oh, Flow, I've never used this. That's such a weird thing. Why would we want that? And I think it was actually almost like a blip in a React community only, which is quite interesting. And TypeScript is significantly older than Flow, and it's been around for much longer. So if you're in the Microsoft community, especially if you're doing C# and Angular, you will have known TypeScript for ages. Well, but I don't want to use TypeScript. So I think this is a personal thing, and maybe it's just because I've been doing it for a couple of years, but I don't like using VS Code. I don't like inheritance. I don't like classes. I just want to write something else. And I was just wondering, is there something else out there? Well, let's just take a step back and have a think. Do you even care about static type checking? Like, could I just write vanilla JavaScript? If I don't care about static type checking and I'm willing to take the risks, yeah, why not? Go vanilla. Like, you don't even need a compile step. Go crazy. But if I do care about the reliability and long-term maintainability of my application, I can always go back to Flow, because it does work. Well, but what if I could use a proper type language? Now, let's go back to this picture. On the front end, JavaScript is king, but this is actually not quite true, because we've discussed two alternatives. We discussed Flow and TypeScript, but there are more. If anyone knows these icons, this got Reason, Elm, and there's an honorable mention to WebAssembly. So I'm just going to go into all of these alternatives quite quickly. In fact, first I'm going to have a drink. Here's one I poured earlier. Oops, sorry. Right, so first thing, Reason. Again, if you're in the React community, you'll definitely know Reason. Reason is actually, it's quite an interesting thing. It's almost like it's syntax sugar on top of this really old language called OCaml. So it's kind of, if you do functional JavaScript, it won't be very hard to pick up because it was designed to be for JavaScript developers as an alternative for a statically typed JavaScript. And if you look at this function, like it kind of looks like a normal JavaScript arrow function, like with Flow. You know, it's not far off. Like I could read this, and so can you. If you want to read more about ReasonML and just the idea of why it was created, how to use it, like who's using it, like why would you, I would recommend going to the ReasonML github.io documentation and just browse at your leisure. But I have added a little Reason code snippet here so you could have a look at what it does. So this is actually a React, like a little React application that just, it's basically a hello world, which I copied. And you can see that you can use JSX. There's a bit fewer brackets. The syntax is a little bit different. String concatenation is a little bit annoying. But other than that, it looks readable. And it's statically typed. And the other alternative is actually Elm. Now, I really love Elm. I think Elm is really exciting. And it's written by this guy called Evan, who used to work for Google. And its main selling point, why people should or could use it, is actually because they promise that you get no runtime exceptions whatsoever, which is quite a big claim. But nowadays, there have been people who've actually been using Elm in production for years, and they confirm that it's pretty much true. And all the runtime exceptions they do get, they can go to Evan and go like, hey, you promised that this wouldn't happen, and he'll fix it. I guess the downside, if you come from JavaScript, is that it looks wildly different. So this is just an Elm function that adds two numbers together. You can see that the syntax is quite different, the typing is quite different, and it will take, the learning curve for this will obviously be quite big. And here's an actual Elm program as well that I copied from, I think, elmlang.org. And it basically is just a counter that you'll render in your browser that you can add or remove values. And you can see that the way that you add HTML is quite different. You don't have any JSX type syntax. It's array-based, which is quite hard to read when you're not used to it. And also, all the indentation looks a bit weird. But nothing you couldn't get used to. And if you want to just hear people talk about Elm, there's an amazing podcast called Elmtown, which is in elmtown.simplecast.fm, which I listen to sometimes going to work because it's very wholesome. They're very nice. Now, why am I talking about all these languages and all this stuff? You probably know a lot of these already. And it's true, you do. But what usually ends up happening is there's like a fad where in some conferences people keep talking about this one language or this one framework for maybe half a year, and then it kind of disappears from the conference venue, and people kind of stop using it. But as a result, people who actually code for work and don't go on this conference circuit don't end up using it in their code bases because they think, well, it's a new fad, it's in alpha or maybe beta, it's not ready, there's no documentation, there's no community. Like, what's the point? I'm going to learn this and then it's going to go away. Well, I just wanted to plot this on a graph so you could see just how old these things already are. So Reason was released in 2016, which is obviously a baby of the bunch. However, as I said before, Reason is just syntax sugar on top of OCaml, and OCaml is as old as JavaScript, having been released in 1996. WebAssembly has an honorable mention, really, because I personally had never used it, but I know that people are looking into it as an alternative, which is only 4 years old. Flow has been around for 5 years, but TypeScript and Elm have actually been around the same amount of time, for 7 years. So especially when you look at TypeScript and Elm, I think, they are alternatives to JavaScript that have been around for a long enough time to have a strong community and actual applications in production that you could use as a reference. And I can't really honestly recommend, despite how much I like Elm for many reasons, I couldn't recommend that, tomorrow at work you go to your boss and go like, oh, let's rewrite this in Elm because it's awesome and you get no runtime exceptions. There is a downside and an upside. So if I plot this in a graph, in my personal opinion, for effort to learn versus reliability in production, obviously JavaScript is way at the bottom because we already know JavaScript and we know that it's not reliable. Flow and TypeScript, if I could, I would have put them on top of each other because I think they are quite quite the same in terms of both reliability and effort. Because if you know Flow, you can kind of type TypeScript, you can figure it out, and vice versa. Reason, given that you already know JavaScript, is a little bit more effort to learn, but it's significantly more reliable. I think especially if you're used to writing functional JavaScript, Reason won't be very hard to pick up. And Elm is completely different. If I could put it higher up in the effort to learn, I would, because it's hard. I've written some hobby projects in Elm for fun, and it's taken me many hours to do simple things. But it's really fun when it works. And finally, because this was discussed, I've added server-fetched partials in this graph. Because I've not actually used them myself, but you know, it feels like there's a ghost of them going around somewhere. So, yeah. So that's pretty much all I wanted to say. Please have a go at something that's not just JavaScript. If you want types, you can. If you want types and you want reliability, you want it quickly, TypeScript is the best thing to learn at the moment because everyone's using it. But if you want something, if you want to go beyond TypeScript and you want the static typing, have a go at Elm or Reason because they're fun and it's good to learn something new. And thank you for riding the type train.
Thank you. Great talk. I have a few more questions for you. If I have already a large JavaScript application and I decide, hey, I want to convert it to TypeScript, how would you go about it? Do you have to rewrite it all, or can you just pick some spots?
Yeah. So actually, with both JavaScript and Flow, you can add it incrementally. With TypeScript, if you remember, I had a slide in which I showed that TypeScript is a superset of JavaScript. And that basically means that all you need to do to convert your code base from JavaScript to TypeScript is to change all your file extensions to .ts, and then add a build step in which you can strip types if you add them. And that means that you don't actually need to add any types at all, but you can start adding them incrementally.
Yeah, so it's very easy to just do like certain parts of your application. You don't need like a big rewrite of it all.
Yeah, definitely. You can start with very, very little. But obviously the downside of this, because you can opt in and opt out, then there's no guarantee that your code will be typed all the way through.
And if I take a step back, how can I decide if I need TypeScript? Because you mentioned like you could go vanilla as well. You don't need types. You can just use the dynamic features of JavaScript. When do you decide like I need TypeScript?
So usually it comes with the size of the team and how often your developers change. So I work at a consultancy, so I always work with lots of developers from the client side and like lots of other Formidables. And it's never me on my own on a project. So if it was me on my own and I write a function that does a thing, I know what it does. I'm unlikely to misuse it. But like as the project goes and as the number of developers get added, you kind of need some type safety just to communicate intent, if anything.
Yeah. Okay, thank you for answering these questions and this great talk. Give another round of applause for Kadi.
Thank you.